Welcome to differentiation using the chain rule. So a reminder that when we differentiate, or the reason we differentiate is to find the gradient of a tangent to a curve at a particular point. So for today we're going to use the chain rule, which is given a function to a power. To differentiate, we're going to bring the power down the front, we're going to multiply it by the differentiation, so what's inside the brackets, and then we're going to rewrite the function and lower the power by 1. So now let's look at some examples. We're going to differentiate 3x plus 2 all to the power of 7, 4 lots of x squared minus 5 all to the power of 6, and the square root of 6x plus 2. So with the first one, 3x plus 2 all to the power of 7. So using that rule that we've just talked about, we're going to bring the power down the front, so the 7 comes down the front. We're going to multiply by the differential inside the brackets. So when I differentiate 3x plus 2, I get 3. And then we're going to rewrite the function and lower the power by 1. So the 7 becomes 6. Tidying that up out the front, so you get 7 3s are 21, lots of 3x plus 2 to the power of 6. With the next one, same rule. So the 4's already there, so it's 4 lots of power down the front, so bring the 6 down, times by the differential inside the brackets. So inside the brackets is x squared minus 5, and the differential of that is 2x. And then rewrite the function, lowering the power by 1. So tidying that up at the front, 4 times 6 times 2x is 48x. Lots of x squared minus 5 to the power of 5. And for the third one, so in the previous video, we looked at changing it to a fractional indice. So the square root is to the power of a half. So the same rule, power down the front, multiplied by the differential inside, so the differential of 6x plus 2 is 6, rewrite the function to the power and lower the power by 1. So a half minus 1 is minus a half. Tidying that up, a half of 6 is 3, over, because it's a negative indice, it becomes on the denominator, the square root of 6x plus 2. So now let's apply it to a question where we're going to find the equation of the tangent. And for this one, it's the x squared minus 3x to the power of 4 when x is 1. So notice that we have x equals 1. So the first step is always going to be find the relevant or the corresponding y value. So find the y value when x is 1. So we sub 1 into that equation and we get y equals 16. Second, we differentiate to find the gradient of the tangent when x is 1. So this differential is a little bit different. So we bring the power down the front, which is the 4. We times by the differential inside. So x squared minus 3x. But because we're going to end up with two terms, make sure you put them in brackets. So that becomes 2x minus 3 when you differentiate that. And then we lower the power by 1. So rewrite your function to the power of 3. We now put the 1 into that y dash to find the gradient of the tangent, and we get the gradient is 32. Putting it into the equation of a line, knowing that the gradient of the tangent is 32 and the point is 116. So into y minus y1 equals mx minus x1, you get y equals 32x minus 16, or in general form, 32x minus y minus 16 equals 0. Thank you.